A water skier starts accelerating to a velocity of 30 meters per second within 20 seconds from rest. What is the acceleration rate as well as the displacement of the water skier? If the force of tension is 1,500 newtons, what will be the force of the person pulling back?
In our physics representation, the person is accelerating in the positive direction. There are two unbalanced forces acting in the x direction in order to observe acceleration. As for the y direction, forces are fairly balanced since the person is being dragged along the surface of the water. The force of tension would have to be greater in order for the person to move forward.
In the interaction diagram, the forces acting in the y-axis include the force of gravity on the earth and the normal force from the surface of the water. In the x-axis, the force of tension from the rope is present, as well as the normal force from the skier holding onto the handle. In this situation, the velocity time graph has a positive slope because the person is accelerating in the positive direction. The acceleration is constant, and as time increases, displacement grows exponentially, as seen in the motion diagram. Newton's second law connects forces and motions. In order to find the displacement and the normal force, acceleration needs to be known as well. Using our givens and the Big Five equations, you can find the acceleration and then the displacement. v2 is equal to v1 plus acceleration delta time aids to finding the acceleration, and delta d is equal to v2 times delta t. Subtract acceleration delta t divided by 2 solves for displacement. In the end, acceleration is equal to 1.5 meters per squared to the right, and displacement is equal to 885 meters to the right.
Now that acceleration has been found, Newton's second law can help find the normal force, where F net is equal to the sum of all forces in the x direction. After isolating for Fn, the normal force equals out to 1,372.5 newtons. Overall, physics can be applied to all situations where forces and motion help explain why objects move the way they do.